clicked into the link that is going to send you to the Conagua webpage, you're going to select or download the data for mean or average temperature for the years from 2019 to 2021. So to do that, you're going to select the corresponding year and you're going to download the mean temperature. So once we do click on this, this is going to open up an additional tab where we can see the mean temperatures for each month of this year for all of the states. So select your state. In my case, I chose Baja California, and record this data for each month into an Excel page. So starting by 2019, I'm going to start recording these values in an Excel spreadsheet. So here's my spreadsheet, and here I have, because I'm starting to count from January of 2019, that month, January of 2019, is my first month. So here I have the first 12. Bueno.
Sí, buenas tardes.
Sí.
¿Con Andrea?
Sí.
¿Cómo le va? ¿Es el repartidor de Walmart?
Claro, aquí estamos.
Sí, pero como, discúlpeme, aquí en la ficha no dice el edificio ni el departamento.
102A. 102 Torrea.
Sí, muchas gracias.
Sí. Now, the next 12 months correspond to the next year. That is for the data for 2020. So again, I'm gonna go into my page. I'm gonna select the year. I'm gonna download the mean temperature for each month, and I'm going to record these values for my state into my Excel spreadsheet. And you're gonna do that with the years 2019 and 2020 and 2021. So here you are going to create this Excel and fill up all the possible values. Obviously, because we are doing 3 years, that means you are going to have values for the first month, that is January of 2019, until the 36th month, que es December of 2021. Okay? Once you have this, you're going to copy your columns, and you're going to open a GeoGebra in your Google, in Chrome. Once you do this, you're gonna open la vista of hoja de cálculo. Here we do click hoja de cálculo, and we're gonna do Control V or copy paste to paste our data. Now we're gonna select these two columns. You can either do this and select all the data and do a right click, and in Crea or Create, you're gonna select Lista de Puntos. So here is our Lista de Puntos. From here, we can temporarily close this tab. So click here in this upper right menu, and in these 3 points, click in Close. Now let's move our graph so we can see those points. Remember, if you put your cursor on the axis and do click in the Shift key on your keyboard and keep the Shift key clicked, you can move your axis, okay? So I'm moving here the values for my axis. I'm doing a little on zoom so I can see all of my points. So you see, this kind of looks like a sine or a cosine. So let's construct the first model. First off, I'm going to click here so I can filter my information in a nicer way. So click here, and select type of object. So we can minimize both the set of points and the list of points, okay? Now here we're going to write the parameters of a general sine or a general cosine function. So I'm going to do a sine. And we know that we have the parameters A, that is the amplitude, B, that is going to define my period, C, that is going to define my phase shift, plus my vertical shift. Don't forget to write this multiplication point right here, otherwise it's going to mark you an error. Enter, and that generates a bunch of sliders that we're going to move to adjust our function to the points. We have exact same thing we did last semester. Now, let's start working smartly. The first thing you have to do is to move your function vertically, okay? What is a smart way to do? To identify the midline in my set of points. You can either do it like this or by ojo. The first thing I'm gonna do is to make a better division of my y-axis. So do a right click anywhere in your plane, right click, vista gráfica, and select eje Y. So here in distancia, select a distance of 1. That way my y-axis is properly marked. So how do we find the midline? As always, I'm gonna find, select or identify my minimum value in my function, that is 12, and my maximum value, that is approximately 28. So the distance between 28 and 12 is 16, so the midline should be at a distance of 8 from either 12 or 28. So the point that is at a distance 8 from 12 is the value 20. So my midline is going to be when my vertical shift is 20. Here's my midline. Okay, now the next thing I'm going to modify is my amplitude. And precisely because we know that the midline is positioned in the middle of my graph, my amplitude should move, in my example, 8 above and 8 below. So I'm going to modify my amplitude correspondingly. Now, once I have selected an amplitude that is according to my data, I'm gonna remove these ugly marks in my points. So I'm going to select my list of points. So I'm gonna do a click in the letter, in the word point, and this is gonna mark all of my points. And I'm gonna remove the labels. So I'm gonna do a right click right here. And in this section, I'm gonna select an invisible tag, much better. Now, once we have selected our vertical shift and our amplitude, we just have to modify the parameters B and C, that is my period and my phase shift, to get a better approximation of this. Remember, you can always select your the limits of your sliders and modify the value accordingly. So I'm gonna start moving my phase shift. So if I move my phase shift right here, my curves have a better fit, but not enough, because my graph looks like this. It is spread apart in a bigger interval, so that means my period has to be bigger. For my period to be bigger, I have to stretch it out, so my B has to be smaller, okay? So for example, if I move my period or my B a little bit, I can adjust again my phase shift. And remember, this is periodicity. You can move either way to get a better approximation. So maybe like this, and then I'm going to modify my B just a little bit more. Remember, if this is just a way too big of a step, I can modify my sliders by clicking in the limits of the slider, and I'm just gonna slide between 1 and 0 for my example. So this is more comfortable, and with a step of 0.1. So this is much more comfortable. So maybe a 0.4, and then I'm gonna adjust again my phase shift. This was way too much, maybe 0.5, and this looks fine. So once I'm happy with my parameters, this has created this function that adjusts my data and created by me. Now, let's create an adjustment made by default by GeoGebra. And to do that, we're going to open again la hoja de cálculo. So to do that, we're going to click on the 3 upper lines, and I'm going to select the option in Vista, hoja de cálculo. Once my data appears once more, I'm going to reselect my data, and I'm going to click here. And then I'm going to select regresión de dos variables. Once I do this, this menu is going to pop up, and I'm going to select my regression model. Obviously, because we're working with trigonometric functions, I'm going to select a sine function. And this gives me the following function. So I'm going to copy this data into my algebraic and graph view. And to do that, I'm just going to click in this button right here, and I'm going to click in copiar en vista gráfica. And that automatically is going to copy the function and its graph into my main space in GeoGebra. So click here, ready. So we can close this section by clicking here, 3 points, and close this tab. And I also don't want to see my page, my hoja de cálculo. So again, I'm going to be going to the upper right menu. In Vista, they select hoja de cálculo. So here I have my both functions, the one I created and the one GeoGebra is proposing. So I have both graphs right here. So I'm going to move this right this way, and I'm going to modify again my axis because I don't want this to look like this. So again, I'm going to put my cursor over the x-axis, and by clicking in the shift key, I'm going to stretch this out because I don't want to see that many months or many values. Remember, each one of these points in X is a month. And I just want to see a little bit far ahead, but not that much. So this is enough. And I'm going to pull this down so I can see my entire graph. There we go. So in green, I have my function, and in red, I have the function proposed by GeoGebra. I'm going to select both by clicking on the Control key. And that selects both of them. And again, in this upper right menu, I'm going to select the label, and I'm going to select name and value. Name and value. So this is going to make my functions appear, and I can move them a little bit so I can see them better, something like this. Okay, so I can see here both of my functions. I can see my plane, and if to put this graph into your file, please make sure that we can only see this space. I don't want to see anything from GeoGebra or your navigator, okay? Well, ready. We don't want to see the lista. We don't want to see the números. We just want to see our functions. And the problem is asking us to find the temperature in our state for the month of March 2022. If we started counting on January 2019, then the month of March 2022 is going to be the month 39. So to find the temperatures given by my model and the GeoGebra's model, I'm going to evaluate each function in that value. So my function that is f minúscula, if I evaluate it in 39, this is going to give me 12. So this f of 39 is my proposed value for March of 2022. On the other hand, the function h, that is a function proposed by GeoGebra, I'm going to evaluate it in 39, and that gives me the value of 15.09. So here's how I can predict the temperature for March, and you can continue with your activity by comparing these values and also analyzing the actual value of the temperature in your state by going back to Conagua and downloading the values or the data for 2022 and comparing all of your data with the real values.